So hey guys, welcome to my channel. I am Sitij and today we will be doing another very interesting problem from the Leetcode Daily Challenge day 25. That is the Leetcode problem number 1029, 2-city scheduling. In the problem statement, we are given a cost array where cost of I is basically a pair of A cost and B cost, where the cost of flying the ith person to the city A is A cost and the cost of flying the ith person to the city B is B cost. Basically, what we have to do is to return the minimum cost to fly every person to a city such that exactly n people arrive in each city. And I believe the question is pretty easy to understand and it will be more clearer when we will discuss the sample test cases. So this is our first test case where we are given 4 pairs of A and B cost array. And we have to find the minimum cost to send half of the people to city A and another half to city B. For the first pair, we see that we are given a value of 10 and 20, out of which we see that 10 is minimum, so we decided that the person 0 must go to the city A. For the second pair, we are given a value of 30 and 200, out of which we see that 30 is again minimum. As a result, we decide that this person must also go to the city A. For the next pair also we are given two values, that is 400 and 50, and out of which we see that 50 is the minimum. As a result, we decided that this person must go to city B. And for the next pair as well, we are given two values, that is 30 and 20, out of which we see 20 is minimum. As a result, we again decide that this person must also go to the city B. As a result, our total cost of sending 2 people to city A and 2 people to city B comes out to be 110, which is our correct output as well. So this is our second sample test case, and here also we are given 6 pairs of cost of sending each person to either to city A or city B. Here we are also given the output 1859, which tells us that the minimum cost of sending these 6 people to either of the city A or city B is 1859 only. Since the explanation is not given, we can't say which people goes to which city. And you might say that all we have to do is to traverse the array and find the mean from the pair and sum it. That should be our answer. Will it be? Let's try. So for the first pair, minimum is obviously 259, so we would be taking 259. For the second pair, minimum is 54, so we will be taking 54. For the third pair, minimum is 667, so we will be taking 667. For the fourth pair, we see that 139 is minimum, so we must take that. In the fifth pair, 118 is the minimum, so we must take that also. And as for the last pair, we see that 469 is minimum, so we must take that. And you might say that the sum of all this value will be the minimum possible value to send all the person to either city A or city B. But here we are missing a very important point, that we have to send n by 2 people in each of the city. So our this distribution where most of the person is going to the city B is actually not correct. So you might say that okay, we will try to find the first n by 2 smallest cost to travel to city A and sum with the rest of the cost to travel city B. Again we will try to find n by 2 smallest cost to travel to city B and sum with rest to the city A. And mean out of both the sum should give us the minimum sum, right? But this approach also doesn't work. So what can be done? Let's see. Let us suppose that we have only two person X and person Y. And for person X, the cost to travel city A is 8 and the cost to travel city B is 10. And for person Y, the cost to travel city A is 15 and the cost to travel city B is 20. Now how would you distribute them such that the cost of sending either of them to either of the city is minimum? Now since we must assign one of them to city A and one of them to city B, now in spite of sending person X to city A and person Y to city B, which nearly gives us 28. The optimal solution would be to send person X to the city B and person Y to the city A, which will give us the traveling cost of only 25, which is definitely minimum than the previous cost we had found. So, D2 we find an observation. We get 3 observations. The first and most important observation is that the relative difference is more important as compared to choosing the cost greedily. In this test case, that is 8 minus 10 minus 2 and 15 minus 20, that is minus 5, we see that the relative difference of person Y is smaller compared to the relative difference of person X. As a result, it would be more cheaper to send person X to city A as compared to sending person X to city A. And since we are bound to sending only one of them to either of the city, we decided that we would send person Y to city B and person X to city A, which would definitely give us the optimal result. Our second observation is that regardless of what the individual cost be, only the relative difference matters. Again, this is evident from the same test case as well. No matter how much the cost of sending person X to city A or the cost of sending person Y to city A be it, only the absolute difference or the relative difference matters. And our third observation is that we have to greedily choose the cost based on the relative difference. We will find the relative difference each of the person to travel in either of the city and sort them. After sorting, we will greedily choose the first n by 2 smallest and last n by 2 values. That would give us the optimal solution. So our algorithm comes out to be something like this. First of all, we have to find the relative difference, that is the cost of ith person to travel through city A minus cost of ith person to travel city B. After finding for each of the person, we have to sort the relative difference in ascending order. If any ith difference is smaller or negative, it means that it will be cheaper to travel to city A. But if any ith difference is larger, it simply means that it would be cheaper to travel to city B. So at the end, we will greedily sum the first n by 2 cost to travel to city B and next n by 2 travel cost to city B. That will be our result. Now let's try to solve our third sample test and see if our algorithm actually works or not. So this is our cost for each of the person, and as our algorithm say, first of all we need to find the relative difference. For this the relative difference is minus 54. For this the relative difference is minus 262. For this the relative difference is minus 172. For this the relative difference is minus 476. For this the relative difference is 76. For this the relative difference is 397. For this the relative difference is 291, and for this test the relative difference is 591. Now as per our algorithm, our second step is to sort the relative order in ascending order. So let's do that. And this is our sorted relative difference. As our n is equal to 8, from our algorithm we see that first n by 2 people must travel to city A and the next n by 2 people must travel to city B. As a result, these 4 people must need to travel to city A and the next 4 must need to travel to city B. So we would sum these values and our sum would come something like 3086, which is actually our correct answer. So we can say that our algorithm is absolutely correct. Now let's see how we implemented this algorithm in our code. So here is our code, and inside our code, and the first thing that we are doing is to find the relative difference for ith person between the cost to travel to city A and the cost to travel to city B, and we are storing it along with the ith index so that in the later value we can retrieve the cheaper cost. Next we are sorting our relative difference in ascending order, And for the last part, since our relative difference array has already been sorted, we can safely assume that choosing first n by 2 people to go to the city A and the next n by 2 people to go to the city B will give us the most optimal result. Thus we are doing the same and returning our sum. Let's see if it successfully execute, which it does, and let's submit to see if our answer is correct or not, which is, and that is how we solve this very interesting problem to city scheduling. Hope you liked my solution. We will meet tomorrow again with some new problem. Until then, keep coding, keep learning.